students, welcome back. Let us continue with chapter 7 triangles, and we will continue with some properties of a triangle. So in the previous class we learned two tests for congruence. Which were they? They were SSS test, which is side angle side test, wherein two sides were equal of two triangles and the angle between these two sides was equal. So that is why it is side angle side or SAS test. The other test that we looked at was ASA test, or you can even say AAS test. That includes two angles and one side of two triangles should be congruent to the corresponding angles and sides of the other triangle. So we also learned a different thing, wherein if we have two triangles wherein all the three angles are equal, then you can't say that they are congruent by AAA test. For example, if I take one triangle ABC, let's say it is an equilateral triangle, so it is 60 degrees, 60 degrees and 60 degrees. I can draw another triangle, equilateral triangle in fact, with the same measurement, 60 degrees, 60 degrees and 60 degrees, and I will call it PQR. Obviously you can see that ABC is not congruent to PQR, the two triangles are not congruent because there is huge gap between the sides. See, if suppose this is, let's say, 5 centimeters and suppose this is 10 centimeters. So it is not sufficient to prove two triangles congruent when all the three angles are equal to each other. You need at least one side that needs to be equal for the two triangles. That is why we have the AAS test or ASA test. So two angles and one side of two triangles are congruent, then the two triangles can be proved congruent. So this was about what we learned in the previous class. You will see about these two triangles when we are proving your SSS test of congruency. SSS test of congruency is nothing but side test of congruency. So if I have two triangles, I will call this ABC and I will call this PQR. Okay. Now, if AB is 4.5 centimeters, let us say QR is 4.5 centimeters, then I take this as 3 centimeters and this as 3 centimeters. Here these are just units, so 3 centimeters for your book, for example. If this is 4.5 units, this is 4.5 units, this is 3 units, and let us say this is 4 units and this is 4 units. Now we can see that the sides are, we have similar sides, right? 4.5, 4.5, 4, 4, 3 and 3. Yeah, can we say that the two triangles are congruent? First of all, what we will do is, we will write the corresponding vertices for the two triangles. So I have two triangles. So I will go from A to B, B to C. So A, B, C. So A to B is 4.5, then 4. So 4.5 to 4. So it is going to be Q, R, P. So A corresponds to Q, B corresponds to R and C corresponds to P. Can we say that the two triangles are congruent? Yes, the two triangles are congruent. How would you prove that? You are going to tilt your triangle in such a way that now this triangle PQR looks like this. Q, R and P. So if you notice, QR is 4.5, then RP is 4, and then finally PQ. PQ is 3. And when you place triangle ABC on top of triangle QRP, ABC will completely hide or overlap triangle QRP. Similarly, if you are going to place triangle QRP on top of triangle ABC, it will completely overlap over triangle ABC in such a way that here you will have QR. If I am placing triangle QRP on triangle ABC, this will become QR and this will become P. So the sides will superimpose each other, the vertices will superimpose each other, corresponding sides, corresponding vertices, corresponding angles as well. So these angles as well. So two triangles can be proved congruent by the side test of congruence, and this you can prove by simply constructing and placing, or probably just taking two triangles with these measurements or any measurements, same measurements, and then placing on top of each other. You will be able to prove this. Please try this while you have some free time. So what does the theorem 7.4 state? It is based on the side test of congruence. It reads, if three sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent. Congruent by which test? Side test of congruency. So if three sides of one triangle are congruent to A, B, C. So if three sides A, B, B, C and CA are congruent to three sides of the other triangle, that is QR, RP and PQ, then the two triangles ABC and triangle QRP are congruent by the side test of congruence. So now you must be wondering that if I have two angles where the three angles of one triangle are equal to three angles of another triangle, you can't really prove them congruent, correct? You can't prove them congruent. But for two triangles that have three sides equal, then the two triangles are congruent. Why? Because in this case, like I said, if this is 60 degrees, this is 60 degrees and this is 60 degrees, I can have another triangle of maybe even a small size, a triangle of a size as small as this, and a triangle of a size as small as this, which is equilateral. So this is 60, this is 60 and this is 60. Similarly, each of these side is each of this angle is 60, 60 and 60. So in these cases where you have angle of two triangles equal to each other, then you can't really say whether the two triangles are congruent or not, because they may or may not superimpose each other. In most cases they won't. However, in case of the side test of congruence, you have the sides that are equal to each other. So obviously the sides are going to overlap and the triangles are going to overlap each other completely, and there is a one-to-one correspondence. So what do we conclude? We have side test, which is SSS test of congruence, whereas we do not have Aaa test of congruence. So this was one of the property that we learned, was SSS. Now let's move on to another property, which is also known as the right angle hypotenuse side test. So let's see this. We'll take a look at the theorem statement later. If I have two triangles, two right angle triangles, let's say A, B, C and P, Q, R. Do we know what this side is known as? The side opposite the right angle, it is called the hypotenuse. So according to the hypotenuse side test, as the name suggests, if you have one right angle and if the hypotenuse and any one side are equal, then the two triangles are congruent, and this is the hypotenuse side test. So let's read it out. If in two right angle triangles, if in two right angle triangles, the hypotenuse and one side of the triangle are equal to the hypotenuse and one side of the other triangle, then the two angles are congruent. So here if I say the hypotenuse is 5 centimeters here and this hypotenuse here is 5 centimeters and this length of BC and QR is 4 centimeters, the two triangles are congruent by the hypotenuse side test. So one hypotenuse should be equal to the other hypotenuse and one side, any one side should be equal to another side. So even if I had, let's say this as 4 units and this was 5 units, we have the hypotenuse equal and I have one side equal to another side. Can we say that the two triangles are congruent? Yes, of course, because these two hypotenuse are equal to each other, that is for triangle ABC and triangle PQR, and any one side is equal to another side. So in this case now, the earlier case when I had this as 4, which two triangles were congruent? I had triangle ABC congruent to triangle PQR, right? But if I change this side as 4, only the correspondence will change, but the two triangles will be congruent. For example, I have now ABC. So now this triangle will no longer stay as PQR, but according to the correspondence it will be RQP. So now triangle ABC is congruent to triangle RQP. Let's see how. So A to B where there is nothing, and then B to C is a single dash. Similarly R to Q is nothing, and then you have Q to P where you have a single dash. So here the two triangles are congruent. So any two sides and hypotenuse has to be equal to each other to prove that the two triangles are congruent by the hypotenuse side test. Now please note, you must be wondering that, but I have two sides and one angle congruent, so why aren't they congruent, the two triangles congruent by the SSS test? That is because the angle is not lying between the two equal sides. The angle between the two equal sides is this and this, right? But it's not given that angle P is equal to angle C. Here you have the angle that is away, which does not lie between the two sides, and we have already seen while proving SSS test that if the angle is not lying between the two equal sides, then the two triangles cannot be proved congruent. So this was theorem 7.5. Now let's read it out once again. If in two right angle triangles, so these are my right angle triangles, if the hypotenuse and one side of the triangle, so if the hypotenuse and one side of the triangle are equal to the hypotenuse and one side of the other triangle, so are equal to the hypotenuse and one side of the other triangles, then the two triangles are congruent to each other by the hypotenuse side test of congruence. And you even call this, while proving, you can just cite RHS test. So RHS in this case is not right hand side, but it is the right angle hypotenuse side test. So right angle hypotenuse side test of congruence. So these were the two theorems. Now we are going to look at the solved examples on pages 126 to 127. So since you see that we do not have a lot of space, I am erasing this section in order for us to solve the questions. So now we have been given that AB is equal to BP. AP is equal to BP, which is marked by single dashes. Then I have AQ equal to BQ. AQ is equal to BQ. I need to prove that PQ is the perpendicular bisector of AB. So what do I need to exactly prove? One, that PQ is perpendicular to AB, correct? And that is each angle PQ is perpendicular to AB. That means either PCA is equal to PCB, which is equal to 90 degrees, or CQA is equal to QCA is equal to angle QCB, which is equal to 90 degrees. So that is the way of proving these two angles perpendicular, that is PQ perpendicular to AB. And also we need to prove that PQ is the bisector of AB, which means I need to prove that AC is equal to BC. Correct? Bisecting something means dividing it into two equal halves. That means PC is dividing AB into two equal halves. So the two equal halves would be obviously AC and BC. So now if I take the two large triangles, that is PAQ and PBQ, I can prove the two triangles congruent by side test. So which are the three equal sides? PAPB, then QAQB, and this is the common side. Therefore the two triangles PAQ and PBQ are congruent by the side test of congruence. Obviously then I can say that two angles are congruent. So which are my two angles? APQ and BPQ, which is APQ and BPQ. So I will just go a little ahead of Q and restrict it to point C. So I will say therefore APC is equal to angle BPC by corresponding parts of congruent triangles. And also Now I can say that these two triangles, that is PAC and PBC, are congruent by the side angle side test of congruence, because we just proved that these angles are congruent. I have this side and this side, also this side as common. Therefore, the two triangles are congruent by the side angle side test of congruence. So far we have proved two triangles congruent, that is the huge triangle and the two upper triangles, right. Therefore, I can say that angle ACP is equal to angle BCP. Why? Corresponding parts of congruent triangles. But if you see that ACP and BCP, they make a linear pair. So if I say if each of the angles is x, then 2x is equal to 180 degrees. Therefore, x is equal to 180 divided by 2, which is 90 degrees. Therefore, each of the angles is, that is ACP is equal to BCP, which is 90 degrees. Therefore, I can say that PQ is perpendicular to AB. Similarly, now proving AC is equal to BC is very simple. Just because we proved that these two triangles are congruent, the two upper triangles, AC is equal to BC by corresponding parts of congruent triangles. So let's go ahead and write the proof. So here, or should I just write the proof here and then we'll erase and write it for question number 8 as well. So my 7th one, proof. So this is part 1 where I am proving the two large triangles congruent. In triangle APQ and triangle BPQ, what do I have? I have AP is equal to BP given and AQ is equal to BQ. I will say this is given, right? And also I have PQ is equal to PQ. And here I will say common side. Therefore, triangle APQ is congruent to triangle BPQ, SSS test. Therefore, I have triangle APQ is equal to triangle, therefore I have angle APQ is equal to angle BPQ. Angle APQ is equal to angle BPQ by corresponding parts of congruent triangles. See, now we had learned that we had to prove the two upper triangles congruent to each other. So I will need angle APC is equal to angle BPC, which is now I am just going to rewrite APQ as APC and BPQ as BPC and use it for reference while proving the two triangles congruent. Therefore, angle APC is equal to angle BPC, and I will mark this as 1. So now my second part, in triangle APC and triangle BPC, I have what? AP is equal to BP, which is given. I have angle APC is equal to angle BPC, so I will say from 1, and PC is equal to PC, common side. Therefore, what do I have? Therefore, triangle APC is equal to triangle BPC by side angle side test of congruence, SAS test. Therefore, what can I say? That angle PCA is equal to angle PCB. By corresponding parts of congruent triangles. So now we are proving 1. So I will just write 1 here. But PCA is equal to PCB, but PCA plus angle PCB is equal to 180 degrees, right, by linear pair axiom. So I will say over here PCA is equal to PCB for some and let it be equal to x, and just rewriting it. Therefore, what do I get? X plus x is equal to 180 degrees. Therefore, 2x is equal to 180 degrees. Therefore, x is equal to 180 divided by 2, which is 90 degrees. Which means what? That PCA is equal to PCB, which is 90 degrees. Therefore, angle PCA is equal to angle PCB, which is equal to 90 degrees. I'll mark this as 2. Or rather, I'll just say, therefore, PQ is perpendicular to PC is perpendicular to AB. But if I extend PC a little downwards, it becomes PQ. So I get, therefore, PQ is perpendicular to AB. And I'll mark this statement as 2. Right? Now again, so my second part, that is the small Roman number 2. We have the two triangles congruent, that is APC is equal to BPC. Correct? Triangle APC is congruent to triangle BPC. Therefore, what do I have? AC is equal to BC. Why? Corresponding parts of congruent triangles. Correct? Therefore, what can I say? That PQ is bisecting AB. PQ bisects AB. So what can you say from points 2 and 3? That PQ is the perpendicular bisector of AB. Therefore, PQ is the perpendicular bisector of AB. And what reason you will give? From 2 and 3. Simple enough. So let's erase the board once again and solve, prove question number 8. That is solved example 8 of your textbooks. So the 8th one, we have this diagram here that PB is equal to PC. That is, PB is the altitude on line L and PC is the altitude on line M. Right? What do you need to prove? You need to prove that AP bisects the angle between them. Therefore, AP bisects the angle, this angle is getting bisected, you need to prove it. I'll mark it with a red colored chalk. That means we need to prove that BAP is equal to CAP. So, BAP is equal to CAP. Correct? So, when it is getting bisected, these two angles should be equal. So, how are we going to prove that? So, if you see the two triangles, that is these two triangles here, BAP and CAP, what do I get? I have this as the right angle, correct, for both the triangles. So, this is the right angle, this is the right angle. Therefore, my hypotenuse here is common. Therefore, the hypotenuse for both the triangles are congruent, are equal to each other. Also, I have one side equal for both the triangles. Therefore, obviously, I can say that the two triangles are congruent to each other by the hypotenuse side test. That is the right angle hypotenuse side test or RHS test of congruence. Therefore, what can I say? That angle BAP is equal to angle CAP. Why? Corresponding parts of congruent triangles. Simple enough. Let's prove it. So, I will say proof for the 8th one. In triangle BAP and triangle CAP, I have AP is equal to AP and I'll say common hypotenuse. Also, what do I have? That PB is equal to PC, which is given. Therefore, the two triangles are congruent by the RHS test of congruence. That is right angle hypotenuse test of congruence. BAP is congruent to triangle CAP RHS test. Correct? Therefore, angle BAP is equal to angle CAP. Why? Corresponding parts of congruent triangles. Correct? Which is proof. Therefore, I will say AP bisects the angle between them. Therefore, AP bisects the angle between them. Hence proved. So, this was the solved example related to the different tests of congruency that we have learned. We have seen that you have put into application the SAS test, ASA test, side angle test, and the right angle hypotenuse side test of congruence. So, based on all these properties that we have learnt about the triangles, that is related to the congruency of two triangles, in fact 2 or more triangles, we will take a look at the next exercise, that is exercise 7.3 in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.